Welcome! So we are going to use the Sketch, Organize, Solve, or SOS method to find electric fields when they have discrete charges. We'll talk about continuous charges in an upcoming video. So first, when we're sketching, we want to establish a coordinate system. And we want to draw axes. And label x and y. Once we've established our coordinate system, we want to draw all the charges on the coordinate system. And we want to identify our point of interest by labeling it, and usually we label it just right with capital P or something like that. Once we have all of our charges drawn and our point of interest, we want to draw our vectors from each charge to the point of interest. Optionally, if you want, you can also draw the electric field at the point of interest from each of these, but it's not immediately necessary for solving this, and it's not helpful with the Sketch, Organize, Solve system, except at the very end to assess your answer. We'll have other methods for that. So for organizing, our electric field using Coulomb's law is 1 over 4 pi epsilon naught, which is also our K from last week. And then we just have the capital Q charge of the actor over r squared r hat. And so for each actor, the actor charges are the charges that are not the recipient, and we don't have a recipient charge. We want to identify capital Q, the charge of the recipient. And then we find r squared and r hat by finding r vector, which is equal to rx I hat plus ryj hat. And we find rx is the x position of the point of interest minus the x position of an actor charge. Ry is the y position of our point of interest minus the y position of our actor charge. So that's how we find rx and ry. Once we have our vector, then we can find r squared by using Pythagorean theorem, rx squared plus ry squared. And we can find r hat by taking our vector and dividing by the magnitude of r, which we can write our r vector as rx I hat plus ryj hat. And we can write the magnitude as just the square root of this, square root rx squared plus ry squared. This so far should be looking very, very similar to last week's discrete electric forces because there's pretty much the same thing. So for our solve, we are going to find E from each individual charge. We already, in our organize step, found everything that we need to find each E. We found the Q for it, we found the r squared, and we found the r hat. And then we have the principle of superposition, which says the net electric field is equal to the individual electric field's vector sum. So we can find the net electric field is the vector sum of each electric field. And how we can do this is we can use decompose form right, and sum all the EXs, then sum all the EYs. If we do this, then we can use scalar math for this. After we've done that, we want to then, of course, simplify. And check our answer. So as we check our answer, then we can go back to our sketch step and draw the individual electric fields now that we've done all the math involving the R vectors and done all that and don't confuse ourselves. Or we can just check which direction we expect it to go. So this is how we use sketch, organize, solve to find electric fields of discrete charges.